Hello everyone, myself Saumesh Rippy, Assistant Professor, Department of Computer Science and Engineering. In today's session, we will be studying about the Module 2 of the Unix System Programming subject. So that is Unix files. As we all are aware of that, in Unix operating system, everything is in terms of files, okay. So whenever we are trying to execute any command which in turn executes the files, whenever we are executing a Unix command, so it will bring the executable file from the file system and it will fetch the instruction and it will store that instruction to the memory and it creates the further process in order to execute the command. So that's why we can say files are nothing but the building blocks of Unix operating system, and also that's why it requires efficient file management system for Unix operating system. So here, what is a file? What exactly a file? File is nothing but a storage of information, okay. So there are different types of files available in Unix or POSIX system. POSIX, that is portable operating system interface, you have already studied in that previous module, that is module 1. So let us look into the types of Unix files, okay. First one is regular file. Second one, directory file. FIFO file. Block device file. And then character device file. Let's look into these files one by one. First, let me consider the regular file. A text file or a binary file can be a regular file, okay. So a regular file can be accessed based on the access permission given to the particular user, and these regular files can be created, it can be read or it can be browsed through, or it can be modified, and also it can be removed by using specific commands that are available in Unix operating system. Already in the previous module we have studied about few commands. For example, rm command removes a particular file. Same way, okay. A command can be used in order to create, modify or remove a file in the Unix operating system, that too particularly regular file, okay. So any text or binary file could be a regular file, okay. So that is all about regular file. Next is directory file. Directory file, as the name itself says, it is nothing but a folder file. It's a directory, okay. It's a folder that contains other subdirectory files and also other files. So it's a folder file that contains other files and subdirectory files. Okay, here the files are arranged in the form of tree. It's like a hierarchical tree structure, okay. So directory files can be created by using the command mkdir. Example I will write here like this, mkdir. So this is the command to create a directory file. Let me take the example like this. am creating the directory 1, it is nothing but a directory file under the folder or under the directory USR by using the command mkdir. Okay. So, similarly, a directory file can be removed by using rmdir command. I will take one more example. In this example, I am removing the directory file dir2 by using rmdir command. Okay. So, that is all about regular file and then directory files. We look into the next files. So, next we shall study about device files. Okay. We will take up FIFO file later. Device file. A device file can be of two types, either it can be block device file or it can be character device file. Okay. So, block device file or character device file. I will just write like this, block device file and then character device file. So, block device file, it represents a physical device in which the data transfer takes in terms of block. Okay. The name itself says. Here the data transfer takes in terms of blocks, where in case of character device file, it represents a device file in which the data transfer takes place in character based manner. So, here one block after another block, whereas here one character after another character. So, the example for block device file is normal hard disk drive, okay, and then the data what we are reading from DVDs and pen drives, all those will be example for block device file. For character device file, it can be modems, line printers, okay. So, sometimes a device can be of both block device type as well as character device type. In that case, application program decides in what mode of data transfer has to be done. Got it? So, it can be of either block file or it can be of character device file. So, in such cases, application program will decide, so in what mode the data transfer has to takes place. Okay. So, device file can be created by using the command mkdir. So, this is the example to create a character device file SDSK by using the command mkdir. Okay. So, here, so mkdir is the command which is used to create the device file, and this is name of the file followed by C. Here C represents it is character device file. If it has to be block device file, then B should be used instead of C. And next we have this parameter, that is nothing but major number. So, we call it as major number, and the last argument, last parameter is minor number. So, major number, it represents the index to the kernel table that contains the different device driver functions that is associated with particular device. Okay. Let me repeat once again. This major number, or it can be a major device number. So, this indicates the index in the kernel table, the index in the kernel table which contains the different device driver functions with respect to different devices. Okay. So, this is with respect to major device number. Next, minor number, it is an argument that is passed to the device driver function, and that value indicates what type of input buffering can be used for this device file. Got it? Let me repeat once again. This minor device number, it is an argument to the device driver function, and it decides what input buffering scheme has to be used for data transfer using this in this device file. Okay? So, this is all about device files. Now, let us look into the FIFO files. So, next is FIFO file. FIFO file represents a pipe. It's a pipe file that contains the buffer, or it provides the buffer, temporary buffer, which is responsible for the data transfer between or the communication between the two processes. Okay? So, here the buffer, this pipe file or FIFO file, it provides a temporary buffer, so which is used for communication between two or more processes. Okay? And here the size of this buffer is decided by the parameter or decided by the manifested constant, that is pipe underscore buff. Okay? And so, here the data is accessed in first out manner, that is why the name is given as FIFO. So, here the data is accessed in first out manner. Okay? And next point says that, so here the buffer will be created whenever a process tries to open the pipe file. Okay? Whenever a process will try to open this pipe file or FIFO file, a buffer will be allocated, a buffer will be created. Similarly, a buffer will be discarded or deallocated whenever a file is deleted. Okay? So, here everything happens with respect to buffer. So, buffer allocation takes place whenever a process is opening the FIFO file, and buffer gets deallocated when the particular FIFO file is deleted by a process. And we can make use of mkfifo command in order to create a FIFO file like this. mkfifo So, this is the name of the file which I am considering here. So, either I can make use of this mkfifo command, or I can make use of mknod command with the option P. Okay? So, here we can make use of either of these two commands in order to create a FIFO file. One is mkfifo followed by the path and name of the FIFO file, and second one mknod command. If you remember, for device file also we have used mknod command. So, here again mknod command with the path and file name followed by P. So, P represents we are considering the FIFO file. Okay? So, here FIFO file can be removed by using rm command. So, it can be removed by using rm command. Okay. So, now let us see what exactly a symbolic link file. A symbolic link is nothing but a path name that refers to the file in either local or remote system. Okay. So, symbolic link file, symbolic link is nothing but a path name that refers to a particular file. Either it can be in the local system or it can be in the remote system. So, here another type of file is symbolic link file. So, the BSD UNIX and SV4 both versions of UNIX system will support this symbolic link file type of files. Okay. So, symbolic files can be created by using the command ln with an option -s. Command is used to create a symbolic link file, and here -s indicates it's a symbolic link, okay, and then this is the particular symbolic link file which refers to the path name like this, okay. So, this is a particular symbolic link file followed by the path name to which this link file refers. So, this is all about symbolic link file, and one more point about symbolic link file, that is POSIX.1 does not support symbolic link file. So, POSIX.1 does not support this symbolic link files. So, that is all about different types of files that are available in UNIX or POSIX operating system. So, let us look into this one by one. First one is regular file, and then directory file, FIFO file, and the device file that can be of two types, block device file and character device file. In addition to these files, one more file, that is symbolic link file. So, now let us move on to the next concept, that is UNIX and POSIX file systems. Next concept is the UNIX and POSIX file system. So, here in UNIX and POSIX file system, the files are arranged in the form of tree-like hierarchical structure. So, that is the first point. It is arranged in the form of tree-like hierarchical structure. So, here the root node starts with the symbol /. So, this represents the root node, and the leaf nodes can be either some other directory files or any other files, okay. So, here we have two types of path names. One is absolute path name and second one is relative path name. So, one is absolute path name and second one relative path name. So, what do you mean by absolute path name? So, absolute path name is the path name in which the file refers, in which the file is represented starting from the root node. So, if it is represented starting from the root node, for example like this, user this is absolute path name representation. Next, relative path name. Relative path name is represented by using the current directory and by referring to the parent directory. So, this can be represented by using dot or double dot, okay. So, here single dot indicates current directory, wherein double dot indicates parent directory. So, single dot represents current directory, double dot represents parent directory. For example, if I am trying to access a particular file, for example like this, dot / double dot login. So, this refers to a file, login file, with the 2 levels up in the directory, okay, 2 levels up in the directory. So, this is an example of relative path name. So, now the file name and path name can be supported by POSIX.1 standard. So, POSIX.1 standard has 2 manifested constants, that is, one is POSIX name max, POSIX name max, and another one is POSIX path max. This constant will provides the limits for the maximum length of the file name, whereas the second one, the second constant, gives the limit for the maximum length of the path name, okay. These two constants are defined in limits.h header file. It is defined in limits.h header file. So, generally the file name can be chosen from either of these characters, lowercase a to z, it can be a combination of capital A to Z, or it can be combination of digits 0 to 9 like this. Okay. Similarly, path name could be a hard link. Okay. It can be represented by the hard link. Actually, there is a difference between hard link and the symbolic link. Symbolic link we have already studied in the type of file, that is symbolic link file. Symbolic link is also called as soft link. So, there is a difference between hard link and symbolic link or soft link. So, what is that? Symbolic link refers to a particular path name, which in turn refers to a different file. Either it can be a local system or remote system. Okay. Anyways, it refers to a path name that refers to different file. When in case of hard link, it directly refers to the file. So, that is the difference between the hard link and the symbolic link. Okay. So, here the path name refers to giving the hard link to a particular file. So, this can be done by making use of the command ln command. So, this is we are creating a hard link for the particular file. Okay. So, observe here, if we make use of -s option, then we are creating symbolic link. If we are just writing ln command, we are creating hard link. So, this is all about UNIX and POSIX file systems. Now, let us list out some of the file systems that are available in the UNIX operating system. These are the UNIX file system that are most commonly defined in UNIX operating system. Okay. The first one is /etc. It's one type of file system that stores the system administrative files and programs /etc. Next file system is /etc/passwd. So, this file system stores the password related information of the user. And next /etc/shadow. So, this file system, it stores all user related information. And then /etc/group. This file system stores the group information system. And then this one /bin. So, it provides it stores the different system programs which can be generated by using the commands like rm, cat command, etc. Okay. /bin is a file system that stores the information of all system programs, nothing but the commands. Okay. Next /dev. So, this particular file system, it stores either block device file or the character device file information. Next, user include. So, this file system stores standard header files. So, that is why the name is given as include. Next one /usr/lib. So, name itself says it stores standard libraries. Okay. And next /tmp, it stores all temporary files that are generated by the program during execution. So, these are all the UNIX most commonly used file system in UNIX operating system. Now, let us move on to the next concept, that is, so these are the different file attributes of a particular file that is available in UNIX and POSIX operating system. So, the general commonly observed the file attributes are: first one, file type. It specifies the type of the file, whether it is a regular file, whether it is a device file, or it is a directory file, and so on. And second one is access permission. It specifies the permission given for the owner, group and others in order to access that particular file. Okay. Next, hard link count. It specifies the count of hard links for that particular file. Next, UID. It represents the owner's user ID of that file. Okay. And GID, it specifies the group ID of that file. Next, file size. It specifies the size of that particular file. And then inode number, it is a special number given, it is a unique number that is assigned for each of the file. So inode number specifies that particular inode number of the file. Next, file system ID, it specifies the file system ID of that particular file under the file system of Unix operating system. And next, last access time, it represents the file last accessed time. Then last modified time, it represents the last modified time of that file. And then last changed time, it represents the last changed time of that particular file. So these are all the file attributes of a file in Unix operating system. In addition to these file attributes, a file also stores major device number and minor device number. Okay. The major device number and the minor device number we have already discussed when we were discussing about the block device and character device file. Okay. So in addition to these attributes, a file will have the major device number and minor device number. Whenever a file is created, these attributes, the file along with these attribute information will be stored in the kernel. Here many of the attributes remains constant, okay, and many of the attributes will be changed depending on the different system call or different command. System call is nothing but a particular built-in function. The execution of system call nothing but the execution of that built-in function. Okay. Few attributes remains constant and few attributes will be changed based on the system call or the command. Now let us see what are all the attributes remains constant and what are all the attributes that will be changed based on the system call. Among the different file attributes that we have discussed just now, these 4 attributes remains constant throughout the survival of the file, okay, throughout the span of the file. So what are those attributes? The file type remains constant, and then inode number remains constant, and then file system ID remains constant, and major and minor device number of that file remains constant. Okay. So these 4 attributes of a file remains constant. So next we shall see which are all the commands or system calls that will change the file attributes. Among that, the first one is chmod, that is change mode. So this command correspondingly this system call will change the last access time, last modified time attribute of a particular file. Similarly, change ownership. So the command and the corresponding system call. This command can also be invoked by using this system call. Okay. So this command and this system call will change the user ID, the group ID, as well as the last modified time, last accessed time, and everything. Next is chgroup. So this command changes the group ID. So the particular system call is chown. The same system call is used for this purpose also. So this system call or this command will change the group ID, the last modified time, last access time attributes of a file. Next, touch command utime, again last modified and last accessed time. Next, ln command or link system call, it will change the hard link count of a particular file. And then rm command or unlink system call, so again it will change the hard link count of particular file. Or VI, so VI is a editor we have used in order to modify, in order to create a file, in order to add content to the file. So thereby we are changing the size of the file and the different attributes of the file. So these are all the different commands or system calls that will be changing the attributes of a file. So that's all for today's session. So in today's session we started with module 2 of Unix system programming subject, that is Unix files. So we got to know that files are building blocks in Unix operating system, and efficient file management system is very much required in Unix operating system. And then we discussed about different types of files in Unix system. So there are regular file, directory file, and then block device file, character device file, FIFO file, and along with that we have discussed one more file, that is symbolic link file. We got to know about each of these files one by one in depth. Okay. And then we discussed about the UNIX and POSIX file system. So here the file systems are arranged in the form of a tree hierarchical structure. So it contains a root node and followed by the leaf nodes, and then we can refer to the files either by the absolute path name or the relative path name. Absolute path name means starting from the root directory we will be referring to particular file. Relative path name means by using dot and double dot, where dot represents current directory and double dot represents the parent directory. And then we discussed about how we can add a particular hard link to a file by using ln command. And then we saw few most commonly used file system in Unix operating systems such as /etc, /tmp, /etc/ /passwd. Okay. So then we got to know about the Unix file system attributes, that means attributes of a particular file in Unix operating system. So we came across many attributes like file size, type of file, inode number, file system ID, UID, GID, last access time, last modified time, last creation time, and so on. Okay. So among those attributes, these 4 attributes remains constant throughout the span of the file, whereas the attributes of a file can be changed based on the execution of few commands or based on the execution of some system calls. So those commands are these commands, and these are the corresponding system calls. So hope you have understood today's concept. Thank you.